In this component of the course, we deal with shifts, how we allocate shifts and how we divide time in the shifts, where we put the delays or necessary disturbances, and how we visually represent availability and utilization. If you look at the scheduled hours of a 9-hour shift on a single shift, we have the timeline for 24 hours. We allocate that shift between 7 and 4 in the day. And to optimize our work time, we put unnecessary disturbances on either side. We aim to keep the productive machine hours up, staying within legal constraints, in other words, the basic conditions of the Employment Act, and break times and legal working hours, and maintaining and refueling when needed, but trying to schedule those outside of the working hours. But what happens if we look at that particular shift pattern? What happens to other allowances? Meals, do we have them within the shift? Do we force the operator to eat outside the shift? Or does they have a break in the middle? That instantly drops down your scheduled machine hours and availability. Where do we do our repairs and refueling? As mentioned earlier, we can either do them on the other side, or we can do them in the break times, after the break times, before the shift, or after the shift. The big variable is the disturbances. How do we do the disturbances and how we keep them to a minimum? The ideal thing would be that we scheduled interactions with operation and keep the disturbances in terms of our operational management to a minimum and try and do those other shifts as much as possible. So how does this all work? It becomes more complex if you start allocating longer, more continuous shifts. If you look at 2 12-hour shifts, where do you put your breaks? It becomes a little bit less complex if you do 2 8-hour shifts. It means you can have breaks on either side, early morning or late evening, to do your repairs and maintenance and refueling. But what happens to the shift interchange? There's invariably a bit of a juggling act and time where you have problems where there aren't operators working. You do 2 longer shifts, 2 10-hour shifts, means your machine hours are up, but you're left with the same issue that you've got 4 hours to actually deal with breakdowns and refueling, or the good old simple 8-hour shift right in the middle. Visually, looking at our allocation of time for our scheduled machine hours, we schedule 12 hours for the shift. That means our schedule is 100% of the time. Our available machine hours is obviously 10 hours, with 2 hours of service and repair time that happens within that 12 hours, dropping our availability to 83%. Productive machine hours, 6 hours, because we have operator rest time, some interference, as well as the repair, refuel, and service time. So, if we have to produce 10 cubic meters per scheduled machine hour, we have to produce 12 cubic meters per available machine hour, and we have to produce 20 cubic meters per productive machine hour. This ratio, we understand, is very important because understanding how you eventually cost your system and what time component you cost it over affects the overall cost, as well as the required productivity for those particular time concepts. You can see that if we schedule 12-hour shifts, we know that we've got 120 cubic meters that we need to harvest in 12 hours. If our productive time drops to our availability, which is 10 hours, we need to produce 12 cubes. If our productive machine hours are only 6 hours over those 12 hours, we have to produce double the amount of timber for each hour that we are productive. In terms of shifts in legislation, this obviously differs very much between where you are in the world and how you deal with labor and working hours. How do you maximize your machine uptime? Something to think about. Do you do longer shifts? Do you try and refuel and do maintenance other shift? Do you use day and night shifts? Often day and night shifts are done, or night shifts in particular, because they try and keep the machine hours up. But in general, a lot of challenges arise at night shifts. Support in terms of mechanical support and operational support, as well as breakdowns. If anything's going to go wrong, it will generally happen at night, when the visibility, although these machines have got greater visibility, although if working at night you're required to have greater visibility, there are still issues that happen, as well as safety. Brings us to the next question: when are the greatest occurrence of breakdowns? It depends on who you talk to. Often they say some operators prefer to work at night, some operators don't, but the general rule of thumb is that there will generally be more issues at night and breakdowns. What are your thoughts? Something to think about over the next part of the course. That brings us to the end of shifts, delays, and breakdown times.